Okay, I see I'm live. So, yeah, we continue to read Rust book. Uh, Last time we finished chapter 10 about generic traits and lifetimes. Basically, we read section 10.3, lifetimes. Was quite interesting. Yeah, we found out that the syntax of the lifetimes. Lifetimes basically uh, not for changing lifetime itself, but about defining relationships between different things. Yeah, pretty new concept to me because in other languages I previously used was nothing like this. So yeah, and today we'll start chapter 11, writing automated tests. And let's start with the intro. In his 1972 essay, the humble programmer Edgar Dijkstra said that program testing can be a very effective way to show the presence of bugs, but it is hopelessly inadequate for showing their absence. That doesn't mean that we shouldn't try to test as much as we can. Correctness in our program is extent to which our code does what we intend it to do. Rust is designed with a high degree of concern about the correctness of program, but correctness is complex and not easy to prove. Rust type system shoulders a huge part of this burden. But the type system cannot catch everything. As such, Rust includes support for writing automated software tests. Say we write a function at 2 and that adds 2 to the whatever number is passed to it. This function signature accepts an integer as a parameter and returns an integer as a result. When we implement it and compile that function, Rust does all the function checking and borrow checking that you learned so far. Ensure that, for instance, we aren't passing a string value or an invalid reference to this function. But Rust can check that this function will do precisely what we intend, which is return the parameter plus 2 rather than, say, the parameter plus 10 or the parameter minus 50. That's where test comes in. We can write tests that assert, for example, that when we pass 3 to the add2 function, the returned value is 5. We can run those tests whenever we make changes to our code to make sure any existing correcting behavior has not changed. Testing a complex skill also, we can cover every detail about how to write good tests in one chapter. We discussed the mechanics of Rust testing facilities. We'll talk about the annotations and macros availability to you when writing our test, the default behavior, the option provided by running your test, and how to organize tests into unit tests and integrated tests. So yeah, this is the intro and basically my feeling about tests. They exist for a reason. It's, it's like discussable topic. Different people have different opinion on it. Somebody just say, eh, we don't need test at all. Some use TDD, some completely against TDD, etc. I'm trying to learn integrate more testing in my daily job, and actually now I found places where it just easier to write some functions with writing tests. Like, for example, if I do React Native mobile development and I need some helper function and I need to run the app, test various conditions, it's just easier to write some tests and do many different edge cases just in test than do it manually to test how app behaves. Another place for a test is it's huge for refactoring. Like if you cover your logic with test, then you want to rewrite some behavior. I mean, you don't want to change it, you want like refactor it's maybe break to smaller pieces or something like this. And it's much more easier if it covered with test and you can see if you break something. Maybe another case when you trying to write test, you think more, at least for me, like I'm starting to think about test how can edge cases can be. So you think about more situation where your code can be break. So yeah, and definitely it make your code more bulletproof. This is my experience, but yeah, and for some cases I definitely love to write tests and would be love to find out how to write it in the Rust. So let's start with chapter 11.1, section 11.1 of chapter 11. How to write tests. Tests are Rust functions that verify that the non-test code is functioning in the expanded manner. The bodies of test function typically perform those three actions: set up any needed data or state, run the code you want to test, assert the result what you expected. Yeah, basically something typical, not just for Rust. Let's look at the feature Rust provided specifically for writing tests that takes those actions, which include the test attribute, a few macros, and the should panic attribute. The anatomy of a test function. It is simplest. A test in Rust is a function that annotated with the test attribute. Attributes are metadata about pieces of Rust code. One example is the derive attribute we used with struct in chapter 5. Okay, derive. We definitely use it. Just want to quickly look into it. Derive. Not here. Okay, so the hash, the square bracket, derive, debug. Okay, this is how it looks. So this is attribute. To change a function into a test function, add test on the line before fn. When you run your tests with the cargo test command, Rust built a test runner binary that run the annotated functions and report on whatever each test function passes or fail. So yeah, let's jump straight into it. We again it hashtag square bracket test fn my first test, and we can do cargo test. And you see, yeah, we actually ran it, my first test. And if I do like my second test, yeah, you see, it ran first, it ran second. No assert, so no fails. It also doesn't require like any assert. As I can see, it just ran successfully and that's it. This is treat as a success. Whenever we make a new library project with cargo, a test model with test function in, it's automatically generated for us. Okay. This model gives you a template for writing your test, so you don't have to look up the exact structure and syntax every time you start a new project. You can add as many additional test functions, as many test models as you want. We explore some aspects of how tests work by experimenting with the template test before we actually test any code. We will write some real-world test that call some code that we've written and assert that its behavior is correct. Let's create a new library project called adder that will add two numbers. Okay, let's do this. So cargo new adder lib, right? And here you see, I don't know what is CFG, it sounds like config test. Not much information from the LSP here, but okay. Oh, actually already have a function and already have a test. So cargo test. Yeah, it works. So let's try to fail. One of the rules, it's like when you write in tests, is to make it fail first, because you should you need to make sure that your test working. If you write the test, there is a chance that it doesn't work and you just always receive success, and then you thinking it's testing something, but it actually not. So let's failed it. We can see test, it works, panicked at assertion, failed, left equal right, left 3, so our result is 3, but we expect right 4. Yeah, this is okay. The content of src librc file in your header library should look like listing 11.1. Yep. For now, let's ignore the top two lines and focus on the function. Note the test annotation. Note that the test annotation, this attribute indicate this is a test function. So the test runner knows to treat this function as test. We might also have non-test function in the tests module to help set up common scenarios or perform common operations. So we always need to indicate which function are tests. Oh, you see, there is a config test, we have a module tests, and then we specify a test attribute specifically for this function. So if we just it fails, will it run if we try to run it? No, it's not run, but if we add test here, so you see it was also invoked in this case. Okay. The example function body uses the assert equal a macro to assert that the result, which contains the result of adding 2 and 2, equals 4. This assertion serves an example of the format for typical test. Let's run it to see that this test passes. Okay, cargo compiled and ran the test. We see the line running one test. The next line shown the name of the generated test function called it works. And then the result of running the test is okay. The overall summary test result okay mean that all the tests passed, and the portion that reads 1 passed, 0 failed total the number of tests that passed or failed. Okay. Yeah, nothing basically to discuss here, just do what it do. It's possible to mark a test as ignored, so it doesn't run in a particular instance. We'll cover that in the ignore some test unless specified requested section later in this chapter. Okay, so now we're here and yeah, in the section 2. So we can also pass an argument to the cargo test command to run only tests whose name match a string. This is called filtering, and we'll cover that in the running subset of test by name section. We also haven't filtered the test being run, so the end of the summary shows 0 filtered out. And let me take a look. Running test to result, to paste, 0 failed, ignored, measured, filter out, yeah, 0. Here we have it. The 0 measured statistic is for benchmark test the measure performance. Benchmark tests are, as of this writing, only available in nightly Rust. See the documentation about benchmark tests to learn more. The next part of the test output starting at doc tests other. is for the result of any documentation tests. We don't have any documentation tests yet, but Rust can compile any code examples that appear in our API documentation. This feature helps keep your docs and your code in sync. We'll discuss how to write documentation tests in the documentation comment as tests. Yeah, this is actually sound really interesting, but it's part of chapter 14, so you will see it a bit later. For now, we'll ignore doc test output. Yeah, something we're able to do, definitely. Let's start to customize the test to our needs. First, change the name of the itWorks function to a different name, such as exploration, like so. Then run cargo test again. The output now shows exploration instead of itWorks. I'm actually would like to try, since we already changed function, I would like to change the name of mod and see what happened. Cargo test, and yeah, it shows in the namespace in the path of our functions. Is it actually... Yeah, just here. Okay. Now we'll add another test, but this time we'll make test that fails. Test fail when something in the test function panics. Each time is run in a new thread, and when the main thread sees that the test thread has died, the test is marked as failed. In chapter 9 we talk about how the simplest way to panic is to call the panic macro. Enter the new test as function named another. So your src src lib.rs file looks like listing 11.3. So yeah, let's do it. It fails. We already have prepared it, and just panic macro and cargo test. Yeah, and it failed. We have our message, this test failed. Basically, yeah. Run the test again using cargo test. The output should look like 11.4, which showed that our explanation test passed and another failed. Yeah, just did it. Instead of OK, the line test another shows failed. Two new sections appear between the individual result and the summary. The first displayed the detailed reason for each test failure. In this case, we get the detail that another failed because it panicked at make this test fail on line 10 in the src lib.rs file. And the next section lists just the name of all the failed tests, which is useful when there are a lot of tests and lots of detailed failing test outputs. We can use the name of a failing test to run just the test more easily debug it. We'll talk more about ways to run tests in the controlling how to test a run section. This is next one. The summary line display at the end. Overall, our test result failed. We had one test pass and one test failed. Now that you've seen what the test results look like in different scenarios, let's look at some macros of other than panic that are useful in tests. Checking results with the assert macro. The assert macro provided by the standard library is useful when you want to ensure that some condition in a test evaluates to true. We give the assert macro an argument that evaluates to a boolean. If the value is true, nothing happens and the test passes. If the value is false, the assert macro call panic to cause the test to fail. Using the assert macro helps us check that our code is functioning in the way we intend. So we can do assert files. In this case, we need semicolon here, and then cargo test, and it failed. Oh yeah, cargo test. And this one is working. This one will fail, I guess. Yeah. Yeah, you see assertion failed 1 equal to. This is something expected. So in chapter 5 listing 515 we used rectangle struct and can't hold method which are repeated here in listing 11.5. Let's put this code in the src librc file, then write some test for it using the assert macro. Yeah, let's quickly copy paste it. So can hold, check if our rectangle width bigger than the one we compared, and also same for it's true for height. So rectangle can hold another rectangle is if its width and height bigger than width and height of another rectangle we try to hold. The canHold method returned a boolean, which means it's perfect use case for the assert macro. In listing 11 things, we write a test that exercise the canHold method by creating a rectangle instance that has a width of 8 and a height of 7, and asserting that it can hold another rectangle instance that have width and height of 1. Larger can hold smaller. Yeah, let's do this. I think we don't need this one anymore, and larger can hold smaller. So let larger rectangle, let's smaller. Okay, and we can assert larger can hold it best. Okay. And yeah, as I mentioned before, we need to make sure it fails. Yeah, it failed. Also, we need to check for if the width is bigger, is the height bigger, if both bigger, things like this. Note that we added a new line instead of the test module use super. I haven't done, I guess, this one. What? Okay, use super. Oh, I have it as well. And what does it mean? The test module is a regular module that follows the usual visibility rules we covered in chapter 7 in the space for referring to an item in the module test, in the module 3, sorry. Because the test module is inner module, we need to bring the code under the test in the outer module into the scope of inner module. We use a globe here, so anything we defined in the outer module is available to this test module. We've named our test larger can hold smaller, and we've created the two rectangles instances that we need. And then we call the assert macro and paste in the result of calling the larger can hold smaller. This expression is supposed to return true, so our test should pass. Let's find out. Yeah, we basically already ran it, it was passed, etc. We tried to fail it as well. It does pass, let's add another test, this time asserting that a smaller rectangle cannot hold a larger rectangle. I think I can do copy paste here. So smaller cannot hold larger. And here smaller, larger. Let's see it fail first. Yep. And the correct supposed to be. So yeah, best. Because the correct result of can hold function in this case is false, we need to negate that result before we pass it to the assert macro. As a result, our test will pass if can hold returns false. Yeah, we already did it. To test that pass, now let's see what happened to our test result when we introduce a bug in our code. We'll change the implementation of the canHold method by replacing the greater than sign with a less sign when it compares the widths. Yeah, this is actually interesting operation, and exactly when you do refactoring, when you're rewriting code without intention to change their logic, if you cover your logic with test, you will not do break your implementation. So smaller cannot hold larger still. Okay, but larger can hold smaller failed. Why? Let's quickly check. Oh yeah, so for true we need both both sides should be true, but in this case one is false, and both will be false. Yeah, this is what expected. Our test caught the bug. Because larger width is 8 and smaller width is 5, the comparison of the widths in canHold now return false. 8 is not less than 5. Exactly. Testing equality with the assert eq and assert and e macros. A common way to verify function is to test for equality between the result of the code under the test and the value you expect the code to return. You could do this using the assert macro and passing it an expression using equal operator. However, this is such a common test that the standard library provides a pair of macros, assert eq and assert ne, to perform the test more conveniently. And those macros compare two arguments for equality or inequality respectively. They also print the true values if the assertion failed, which make it easier to see why the test failed. Conversely, the assert macro only indicates that it got a false value for the equal expression, without printing the values that led to the false value. Write a function named add2 that add2 to its parameter. Then we test this function using assert eq macro. it adds 2. So assert equal for add 2. It adds 2, okay, but we still failing for larger can hold smaller. Let's revert our wrong implementation for can hold. And everything pass now. Let's check that it passes. We already did it. We pass 4 as an argument to assert equal, which is equal to the result of calling add 2. The line for this test is okay, and okay text indicate that our test passed. Let's introduce a bug into our code to see that assert equal look like when it fails. Change the implementation of add2 function to instead add3. Yeah, basically this is technique where I talked about before. So we need to make sure our test works so we can rely on it. So we fail, we do mistakes in our implementation to test our tests. And it works correctly. It's back to green one. So yeah, maybe something interesting here. And test it adds 2, panicked at assertion failed, left equal right. Okay. Okay. Yeah, quickly check if anything in the chat. Our test called debug. The it adds 2 test failed, and the message tells us that the assertion that fails was assertion failed left equal right, and what the left and right values are. This message helped us to understand debugging. The left argument was 4, but the right argument where we had add 2 with 2 param was 5. You can imagine that this would be especially helpful when we have a lot of tests going on. Okay, note that in some languages and test frameworks, the parameters to equality assertion functions are called expected and actual, and the order of in which we specify the arguments matters. However, in Rust, they called left and right, and the order in which we pass the values we expect and the value the code produces doesn't matter. We could write the assertion in this test as assert equal at in different direction, which would result in same value message that display the assert ne macro will pass if the two values we give it are not equal and fail if they're equal. Yeah, let's quickly try it actually. So basically can just copy paste it adds 2 not I don't know, something like this. And just do it like this. Cargo run. So cargo test. Yeah, all is good. But if we do fork here, it failed. Left not equal right. Assertion failed. Okay. So macro will pass if the two values we give it are not equal and fail if they're equal. This macro is most useful for cases when we're not sure what a value will be, but we know what the value definitely shouldn't be. For example, if we're testing a function that is guaranteed to change its input in some way, but the way in which the input is changed depends on the day of the week that we ran our tests, the best thing to assert might be that the output of the function is not equal to the input. Under the surface, the assert equal, yeah, in this case we might want to make sure that we assert correct value for each day and we mocked somehow the day is today. But yeah, just for book example, it's fine. Under the surface, the assert equal and assert in E macros use the operators double equal or not equal, respectively. When the assertion fails, those macros print their arguments using debug formatting, which means the value being compared must implement the partial equal and debug traits. All the primitive types and most of the standard library types implement those traits. For struct and enum that you define yourself, you need to implement partial equal to assert equal of those types. You also need to implement debug to print the value. Sorry, I lost my thought. So when your assertions fail, the macros put arguments using debug formatting, which means the value being compared must implement the, okay, yeah. So this is to be able to compare things, and this, I don't remember what debug trait is doing. Let's quickly Google it. Debug trait Rust. All types which want to use std, oh okay, formatting, this is required for formatting. Yeah, got it. So all the primitive type and most of the standard library types implemented those traits. For struct and enum that you defined yourself, you need to implement partial equal to assert equality of those types. You also need to implement debug to print the values when the assertion fails, because most traits are derivable traits as mentioned in listing 512. In chapter 5, this is actually straightforward as adding the derive partial equal debug annotation to a struct or enum definition. Okay. So adding custom failure messages. You can also add a custom failure to be printed with the failure message as optional argument to the assert equal, assert, and in macros. Yeah. Let's try to left, right. Okay, it's not obvious where to do it, so let's quickly read forward. So any arguments specified after the required arguments are passed along the format macro. So you can pass a format string that contains placeholder and values to go in those placeholders. Custom messages are useful for documenting what an assertion means when a test fails. You'll have a better idea of what the problem is with the code. Yeah, definitely we can put something helpful in our test fail, because when you write the test, it's kind of obvious what's going on for you in most cases, but if you back to it in some, I don't know, in half a year, you back to this code, change something, it failed, and it can help you to remember quickly, or if somebody else from your team dealing with it, this additional text could help him a lot. So, for example, let's say we have a function that greets people by name, and we want to test that the name we pass into the function appears in the output. Okay, let's copy greeting function itself and the test. So result contains return boolean, and this is clear. And everything passed. The requirements for this program haven't been agreed upon yet, and we are pretty sure that hello text at the beginning of the greeting will change. We decided we don't want to have to update the test when the requirement change, so instead of checking for exact equality to the value returned from the greeting function, we'll just assert that the output contains the text of the output parameter. Now let's introduce a bug into this code by changing greeting to exclude name to see what the default test failure look like. Sorry. Maybe let's do it like this. So the default failure message is greeting contains name, panicked at assertion failed, result contains Carlos. Okay, that's basically it. This result just indicates that the assertion failed and which line the assertion is on. A more useful failure message would print the value from the greeting function. Let's add a custom failure message composed of format string with the placeholder failed in which the actual value we got from the greeting function. So, okay. Now let's run test. Panicked at greeting did not contain name while while was hello. Yeah, exactly. And let's quickly fix and see how it's look. All is fine. Okay. Now when we run the test, we'll get more informative error. Basically, yeah. We can see the value we actually got in the test output, which would help us debug what happened instead of what we were expecting to happen. Okay. Checking for panics with should panic. In addition to checking return values, it's important to check that our code handles error condition as we expected. For example, consider the guess type that we created in chapter 9, listing 913. Other code that uses guess depends on the guarantee that the guess instance will contain only values between 1 and 100. We can write a test that ensure attempting to create a guess instance with a value outside the range panics. We do this by adding the attribute should panic to our test function. The test pass if the code inside the function panics. The test fail if the code inside the function doesn't panic. So let's see. And now let's just copy paste everything here. So guess new will panic if we pass value outside of the range less than 1 or bigger than 100. And if it panics, the this attribute will work, should panic, and it should pass. So let's do cargo test. Yeah, should panic, and of course let's also try the value which in range and see how it will work. And you see should panic failed, and this is what we want to have. Let's quickly try. Yeah, range from another site. Okay, we are good with should panic attribute. Replace the should panic attribute after the test attribute and before the test function it applies to. Let's look at the result when this test pass. Should panic. Looks good. Now let's introduce bug in our code to be removing the condition that the new function will panic if the value is greater than 100. Yeah, I did it on the test code itself, not on the implementation side. But yeah, generally we should do it like this. But in my case, it doesn't really matter while we're learning. So yeah, we don't get very helpful message in this case, but when we look at the test function, we see that it's annotated with should panic. The failure we got means that the code in the test function did not cause a panic. Tests that use should panic can be imprecise. Okay. A should panic test would pass even if the test panics for a different reason from the one we're expecting. Yeah, that's a good point. Because if we have other condition for panic and it was the case, so test will just pass. Because of wrong condition. So yeah. To make should panic test more precise, we can add an optional expected parameter to the should panic attribute. The test harness will make sure that the failure message contains the provided text. For example, consider the modified code for guess in lesson 11.9, where the new function panics with different messages depending on whether the value is too small or too large. Okay. Let's update our implementation. And here we expected less than or equal to 100, and this is part of this condition, of this panic in this condition. And let's do it. Cargo test. And we are good, but what will happen if we do minus for different panic message? Yeah, it's still fine. Failed even if we panicked, but the message was different. And you see, guess value must be greater than or equal to 1. Got this one. Yeah, this looks pretty nice. I like it. So this test will pass because the value we put in the should panic attribute expected parameter is a substring of the message that, yeah, and it's actually substring. We don't have a full string of this panic. which is also quite nice because this parameter will be different depending on the value, so we cannot compare it because we just don't know. Like in this particular case we knew because we put our value here, but yeah, just substring is a good solution as far as I can see. Is substring of the message that the guess new function panic with. We could have specified the entire panic message that we expect, which in this case would be guess value must be less than or equal to 100 got 200. You choose to specify depends on how much of the panic message is unique or dynamic and how precise you want your test to be. In this case, a substring of a panic message is enough to ensure that the code in the test function execute the else if value. To see that happened when issued panic test with expected message fails, let's again introduce a bug into our code by swapping the bodies of the if value and the else if value blocks. Yeah, I quickly tested with different values again in the test function just to speed up the process. But if you write in the real code, it makes sense to fail your test on the implementation side. The failure message indicated the test did indeed the panic as we expected, but the panic message did not include the expected string. And the panic message that we did get in this case was guess value must be greater than or equal to 1, got 200. Now we can start figuring out where our bug is. And the last piece in this section, using result in test. Our tests so far all panic when they fail. We can also write tests that use result. Result is struct, right? Here is the test from listing 11, one rewritten to use result and return error instead of panicking. So if 2 plus 2 equal 4, then return okay, else return error. Okay, I think I get it, so let's try. It works. So this is works, but if we will fail it, let's see what kind of error we will get. It works, failed. Error 2 plus 2 does not equal 4. So getting the message from the string we put to the error. So this is the value of error struct. Okay. Yeah, this is clear. The itWorks function now has the result unit type or the string return type in the body of the function rather than calling the assert equal macro will return OK when the test pass and error with a string inside when the test fail. Writing test so the return result enables you to use the question mark operator in the body of test, which can be a convenient way to write tests that should fail if any operation within them return an error variant. Okay, makes sense, yeah. The question mark operator was like pretty piece of Rust, so yeah. You can use should panic annotation on tests that use result to assert that an operation returns an error variant. Don't use the question mark operator on the result volume. Instead, use assert is error. Okay. Oh, yeah, just you can't, so you cannot use the should panic, so we need assert value is error. Yeah, got it. Now that you know several ways to write tests, let's look at what is happening when we run our test and explore the different option we can use with cargo test. Okay, so yeah, I think that will be it for today. Tomorrow we will continue with section 2 of chapter 11. Yeah, thank you for watching. See you next time.